All right, guys, we're on the back side of day 10 notes. We're on number 3, and it says that the value of an initial investment of $400 at 3% nominal interest, compounded quarterly, would be modeled by which equation below, where t is the number of years since the investment was made. All right, guys, so we have to think back. Because they said compounded, we have two formulas to use, correct? We have our A of t equals P in parentheses 1 plus R over N raised to the NT formula. We also have our A of t equals P e to the RT formula. Both are compound formulas. But because they said quarterly, we're going to, oops, I didn't mean to do that. Okay. We are going to go ahead and like I said, it's hard to pick my highlighter over my other one. We're going to use this formula right here for compounding quarterly. If they said compounded continuously, we would use the PERT formula. Okay. All right, so if I plug my stuff in the correct spot, we're going to have A of t equal to our initial amount, which is 400, in parentheses 1 plus. Our rate is 3%, which is known as 0.03 as a decimal, divided by our n, which is the number of times we're compounding, and quarterly is 4 times a year. Just think about $4 or 4 quarters in a dollar, right? So we're going to put a 4 under there. And then in the formula, guys, that 4 is as the exponent right now. And then our t, which we don't know the time frame. They told us to use t. Okay. If I look at all my choices, guys, what happens is that they took this stuff in parentheses and they typed it into their calculator to figure out what number that is. So take your calculator, type in 1 plus 0.03 divided by 4. And when you're finished, you're going to have A of t equals 400, because we didn't type that in. And 1 plus 0.03 to the, divided by 4 is 1.0075 raised to the 4t. And you guys can see that that is not choice 3, not choice 4. And the only difference between choice 1 and choice 2 is that choice 1 has an exponent of 4t, which so do we, and so that's our answer. 2 does not have a 4t as the exponent, only a t. Okay? All right, guys, number 4, it says Susie invested $2,000 at a rate of 3.5% per year, compounded, and now it says continuously. And so now, guys, we know that when it says continuously, that we have to use the PERT formula, okay? How much will she have after 10 years? All right, so because we're using the PERT formula, we're going to go ahead and say A of t, or we could also say A of 10 equals P, which is how much we're putting in, which is 2,000, E, which is in our calculator. Our rate is 0.035 when we take it out of a percent. That's the first exponent, times t, which is 10. Again, if you have an old calculator, guys, that whole exponent needs to be grouped in parentheses. Okay. All right, guys, all we have to do is type that in. So again, I'll walk you through it, but type in 2,000, hit your second and your ln key to get the e, and then it gives you an exponent in your screen, and you're going to type in 0.035 times 10. Okay, notice 0.035 times 10 is all up in the exponent for e. If you have the older calculator, make sure your 0.035 times 10 is all grouped in one set of parentheses. Okay. Hit enter, guys, and we're going to end up with 28. So $2,838.135097. Because this is money and there are no rounding directions, we're going to go ahead and take the nearest cent or the nearest hundredth and look next door. And it is a 5, guys, which means our underlying number of 3 is going to go up. And so we're going to end up with $2,838.14. And there is our amount. All right. All right, guys, we have one more formula to talk about. and that's a half-life formula. Okay, again, guys, the formula is just slightly different than our other formulas. It still uses A of t, which is your final amount, or our y value. A of 0, guys, is what they call the initial amount in this one. Instead of a P or an A, now they call it an A of 0 or a sub-zero. Okay. Our time, or well, I'm sure before I get to time period, guys, this 0.5 in here, because this is a half-life formula, it decreases, which is 1 minus a half, because it's a half-life. 1 minus a half, guys, is 0.5, and that's where they're getting that. However, we don't have to really do anything. That 0.5 just stays in our formula, okay? And then it's raised to the t divided by h. T is our time period, and then h is our half-life time period. So we have to be careful that we use the right things in those two spots, okay? And then there's a little note here, guys, that they must be in the same units. So your time period and your half-life time period have to be in the same units. If they're not, we have to convert, okay? All right, guys, so number 5 says that one of the medical uses of iodine-131, known as I-131, a radioactive isotope of iodine, sounds fancy, right, is to enhance X-ray images. The half-life is approximately 8.02 days. A patient is injected with 20 milligrams of I-131. After 5 days, how much of I-131 remains in the patient's body to the nearest hundredth? There's our rounding directions. Okay, so because they're talking about half-life, we know that this is going to be this formula. And so we're going to organize our variables off to the side. Okay, A of t is the amount after, or our final amount, and that's actually what we want to know, how much is being left in there. What's the final amount of I-131 in the body? Okay, A sub 0, guys, is our initial amount. And if you caught it, a patient was injected with 20 milligrams at first. And so that 20 is going to be our initial amount. We don't have to worry about the 0.5. That's just part of the formula. And then we have t divided by h. T is our time period, which is 5 days. And h is our half-life time period, which if you caught the half-life is 8.02 days. Notice, guys, they are in the same units. They're both in days, and so we don't have to worry about that. Okay, so we're going to go ahead, guys, and plug it in. So we can either leave this as A of t, or we can call it A of 5, since our t is 5. It won't affect your answer, so it does not matter to me. Okay, your initial amount is 20. In parentheses will be 0.5. And then raised to the t, which is 5, divided by our h, which is 8.02. All right, guys, all we're going to do is type this right into our calculator, okay? Again, I'll walk you through it. But if you take your calculator, turn it on, type in 20, in parentheses, 0.5, hit your caret button. If you have an older calculator, this entire fraction needs to be grouped in one set of parentheses. Other than that, guys, if you have one of the newer calculators, you'll see that when you type in 5 divided by 8.02, that it's all up in the tiny little exponent, and so you don't need parentheses around it, okay? If you hit enter, we're going to end up with a number of 12.982.41341. And because they gave us rounding directions, that's it to the nearest hundredth. That's the second decimal spot. Look next door. It's not going to move it up. And we're going to say that our answer is 12.98, and this is milligrams. That's how much of the I-131 will be left in the body's system when you started off with 20 milligrams, okay? But there's a half-life, which makes it decrease, and that's what you're left with. All right, in number 6, it says that a population of 950 bacteria grows continuously, okay, at a rate of 4.755% per day. Write an exponential function called n of t that represents the bacteria population after t days. Okay, so all they want, guys, is us to write a function. And because they're saying continuously, we have to make sure that we're using the correct formula, which is our PERT formula. So we're going to go ahead, guys, and say A of t equals PE to the RT. All right, and they asked us to do a couple things. So off to the side, guys, instead of saying A of t, they want us to use N of t. So we have to make sure that we do what they ask. Our P is going to be our population that we started off with, which is 950. E is in our calculator, so we don't have to worry about that. R is our rate, which as a decimal is 0.0475. And our T, they're not telling us what that is, so we're just going to leave it T, okay? So our formula, guys, will turn into N of T equals 950 E to the 0.0475 times T, which is just T. And there is our function. That's what we're going to be using. Okay. So now in the next part, when they said determine the bacterial population after 36 hours. Oops. I want to highlight that. To the nearest bacterium. And so right there, guys, is our rounding directions. All right. So what we have to realize is that there is a little bit of a conversion here. Okay? They gave us our rate per day, but they're asking for 36 hours. Well, we can't change our rate, okay, but we can change 36 hours. And so instead of using 36 as our time frame, 36 hours into days, 24 hours in one day, okay? So 36 hours. If you take 24 away from 36, so you can figure out what's left, is 12. Well, 12 hours is half of a day. And so 36 hours, guys, is 1.5 days. And we had to do the conversion because this rate is per day. And so we have to make sure that they're in the same units, okay? And so we're going to go ahead, guys, and use our formula. N of t, which is actually n of 1.5, or you can leave it t, it doesn't matter. 950 e to the 0.0475 times our t, which is 1.5. All right, now that we have it all plugged in, guys, all we have to go and do is type it exactly in how we wrote it. And we're going to end up with 1020.157172. Okay. And when we round that to the nearest bacterium, it's a funny word. Okay, we're going to round the 0, but look next door, it's a 1. It's not going to change the 0. And so we're going to end up with 1020 bacterium. Or bacteria. Guess that's the plural of bacteria. All right, guys, and so that question is finished. We got one last one to do, and number 7 on the bottom here. It talks about that the half-life of a radioactive substance is 15 years. So notice your keyword, guys, was half-life. That tells you what formula to use. And its half-life is 15 years. Stephen started with 200 grams of this substance. How much will remain to the nearest gram? There's your rounding directions. After 36 months. All right, so because they said half-life, we know that we need to use the half-life formula, which is A of t equal to A sub 0 0.5 raised to the t divided by h. Okay? A of t is our final amount, which we don't know how much is going to remain. So that's what we're solving for. A sub 0, guys, is our initial amount, which they said they started with 200 grams. We need to know our t, which is our time frame, okay, which is 36 months. And our H, which is our half-life, is 15 years. And you guys are going to see that T and H, remember that little side note says that they have to be in the same units? We have months and years. So what we're going to do, guys, is we're going to change our months into years, just like we did in the last question. Okay, so 36 months. Remember, guys, that there's 12 months in a year. So if you have 12 months, that's 1 year. Another 12 months, which is 24 months, is 2 years. And 12 more months would be 36 months. And so that's going to end up being 3 years. Okay. All right. I think we have all of our information. So we're going to go ahead and plug it in. And this formula, guys, is going to turn into A of 3, or you can keep it A of T. Like I said, it doesn't affect your answer. Your initial amount is 200. In parentheses is 0.5. Raised to the T, which is 3 years, divided by your H, which is 15 years. Okay. All we have to do, guys, is type that right into our calculator exactly how it's written. And we're going to end up with 174.110127. Remember, our rounding direction said nearest gram, which is the 4 spot, but we'll look next door. And we're going to end up with A of 3 being 174 grams is our label. All right, so remember, guys, half-life is a decreasing formula or a decaying formula. Notice that we started with 200 grams and it decayed down to 174 grams after 36 months or 3 years. Okay? All right, guys, so that is how we use our formula. So be very careful that you pick the correct one. All right, and plug in your numbers in the very correct spots and just make sure that you check your time frames and make sure that they coincide, that you don't have to use a conversion like we did in the last 2 questions. All right, guys, I will see you on the next day of notes.